Hello, welcome to the course Python Programming for Beginners. In this video, we will discuss about Python libraries. Here, we will see the overview of Python open source libraries, mainly which are used for data science and machine learning. Basics of open source libraries for data processing, modeling, and visualization. We will see the Python libraries related to data pre-processing, modeling, and visualization. All these libraries which are open source. Python, we know, Python is the one of the most popular language used by data scientists, software developers, like data science tasks. It can be used to predict outcomes, automate tasks, streamline processes, and offer business intelligence insights. There are a quite few open source libraries that make Python data tasks much easier. Let us see what are the open source libraries which are used for these tasks. The following are some of the most important libraries for data science tasks available in the Python ecosystem, which covers the areas such as data processing, modeling, and visualization. Related to data mining, the Python libraries are Scrappy, Beautiful Soup. Then related to data processing and modeling, the Python libraries are NumPy, which stands for numerical Python. Then the next one is SciPy, which is scientific Python. The next one is Pandas, which stands for Python data analysis. The next one is Keras. The next one is SciKit-Learn. The next one is PyTorch. The next one is TensorFlow. The next one is XGBoost. Then some of the Python libraries related to data visualization. The first one is Matplotlib. Then the next one is Seaborn. The next one is Poke. The next one is Plotly. Then finally PyDot. These are all the Python libraries for data visualization. Let us see all these libraries briefly. Then coming to Scrapy, one of the most popular Python data science libraries, Scrapy helps to build crawling programs, means spider bots, that can retrieve structured data from the web, for example, URLs or contact information. It is a great tool for scraping data used in, for example, Python machine learning models. Developers use it for gathering data from application programming interfaces. This full-fledged framework follows the don't repeat yourself principle in the design of its interface. Finally, as a result, the tool inspires users to write universal code that can be reused for building and scaling large crawlers. Then the next library is Beautiful Soup, is another really popular library for web crawling and data scraping. If we want to collect data that is available on some websites, but not via a proper CSV or API, Beautiful Soup can help us to scrape and arrange it into the format whichever we required. That is about Beautiful Soup library. The next one is NumPy, which is a numerical Python, which is a perfect tool for scientific computing and performing basic and advanced array operations. This library offers many handy features, performing operations on n arrays and matrices in Python. It also helps to process arrays that store values of the same data type and makes performing math operations on arrays and their vectorization, which is easier. In fact, the vectorization of mathematical operations on the NumPy array type, which increases performance and accelerates the execution time. Then the next library is SciPy. This useful library includes modules for linear algebra, integration, optimization, and statistics. Its main functionality was built upon NumPy, so its arrays make use of this library. SciPy works great for all kinds of scientific programming projects, which includes science, mathematics, and engineering. It also offers efficient numerical routines such as numerical optimization, integration, and others in submodules. The extensive documentation makes working with this library really easy. The next library is Pandas. It is a library created to help developers work with labeled and relational data in Chile. It's based on two main data structures. One is series, that is one dimensional, like a list of items. Another one is data frames, which is two dimensional, like a table with multiple columns. Pandas allows converting data structures to data frame objects, which handles missing data, adding or deleting columns from the data frames, assigning missing files, and plotting data with histogram or plot box. It is a must-have for data wrangling, manipulation, and visualization. Then Keras. Keras is a great library for building neural networks and modeling. It is very straightforward to use and provides developers with a good degree of extensibility. The library takes advantage of other packages, that is Theano or TensorFlow, as its backends. Moreover, Microsoft integrated CNTK, that is Microsoft Cognitive Toolkit, to serve as another backend. It is a great pick if you want to experiment quickly using compact systems. The minimalist approach to design really pays off. Then the next library is SciKit-Learn. This is an industry standard for data science projects based on Python. SciKits is a group of packages in the SciPy stack that were created for specific functionalities, for example, image processing. Scikit-learn uses the math operations of SciPy to expose a concise interface to the most common machine learning algorithms. Data scientists use it for handling standard machine learning and data mining tasks such as clustering, regression, model selection, dimensionality reduction, and classification. Another advantage is it comes with quality documentation and offers high performance. Then the next library is PyTorch, which is a framework that is perfect for data scientists who want to perform deep learning tasks easily. The tool allows performing tensor computations with GPU, which is graphics processing unit, acceleration. It also used for other tasks, for example, for creating dynamic computational graphs and calculating gradients automatically. PyTorch is based on Torch, which is an open source deep learning library which is implemented in C language with a wrapper in Lua. Lua is a lightweight, high-level, multi-paradigm programming language designed primarily for embedded use in applications. The next library is TensorFlow, which is a popular Python framework for machine learning and deep learning, which was developed at Google Brain. It's the best tool for tasks like object identification, speech recognition, and many others. It helps in working with artificial neural networks, that need to handle multiple data sets. The library also includes various layer helpers like TF-Learn, TF-Slim, Escapeflow, which make it even more functional. TensorFlow is a constantly expanded with its new releases, which includes fixes in potential security vulnerabilities or improvements in the integration of TensorFlow and GPU. Then the next library is XGBoost. Use this library to implement machine learning algorithms under the gradient boosting framework. XGBoost is portable, flexible, and efficient. It also offers parallel tree boosting that helps teams to resolve many data science problems. Another advantage is that developers can run the same code on major distributed environments such as Hadoop, SG, which is a SunGrid engine, and MPI, which is message passing interface. The next library is Matplotlib. This is a standard data science library that helps us to generate data visualizations such as two-dimensional diagrams and graphs like histograms, scatter plots, non-Cartesian coordinate graphs, etc. Matplotlib is one of those plotting libraries that are really useful in the data science projects. It also provides an object-oriented API for embedding plots into applications. Python can compete with scientific tools like MATLAB or Mathematica. However, developers need to write more code than usual while using this library for generating advanced visualizations. Here, note that the popular plotting libraries work seamlessly with Matplotlib. Then the next library is CBOR, which is based on Matplotlib and serves as a useful Python machine learning tool for visualizing statistical models, heat maps, and other types of visualizations that summarize data and depict the overall distributions. When using this library, we can get to benefit from an extensive gallery of visualization, which includes complex ones like time series, joint plots, and Venn diagrams. Then Bokeh is the next library, which is a great tool for creating interactive and scalable visualizations inside browsers by using JavaScript widgets. Bouquet is fully independent of Matplotlib. It focuses on interactivity and presents visualizations through modern browsers, similar to data-driven documents like D3.js. This D3.js, which is a JavaScript library which provides dynamism, interactive data visualization in web browsers. It also makes use of scalable vector graphics, HTML5, and CSS standards, cascading style sheets. It also offers a set of graphs interaction abilities like linking plots or adding JavaScript widgets and styling formats. Then the next library is Plotly. This is a web-based tool for data visualization that offers many useful out-of-box graphics. We can find them on the plotly.ly website officially. The library also works well in interactive web applications. Its creators are busy expanding the library with new graphics and features for supporting multiple linked views, animation, and crosstalk integration. The next library is PyDot. This library helps to generate oriented and non-oriented graphs. It serves as an interface to GraphViz written in pure Python. We can easily show the structure of graphs with the help of this library. That comes in handy when we are developing algorithms based on neural networks and decision trees. These are all some of the open source Python libraries which are used for data processing, modeling, and visualization. In upcoming lectures, we will see some of the important libraries in detail. Till that, stay tuned for latest updates.